Okay, this is the fourth and final video in the trig graph series that I've been working on. This one will look at the final type of trig graph you will see in National 5, which is graphs that have been moved up or down. So you should have already seen graphs that have been moved left or right and be well aware of the difference between the amplitude and the number of waves. So what you might see is there'll be an extra bit here. The end number tells us how much has been moved up or down, very similar to in straight line. A wee recap, that A was amplitude, that was the maximum height of the graph, and B was the number of waves. I won't necessarily do any with that though, that would be more into the higher course, but there will be numbers that they will be using an A and they will be using a C. Okay, so as always I've started with the basic graph y equals sine x. Now the first thing we have to do is we have to work out the total height of the graph. The connection here helps us get the number in front of the graph and then how much it's moved. Now your normal sine graph goes from 1 to -1, that's a total height of 2. And if you do 2 divided by 2, you get 1, which is the secret number 1 that's in front of the sine x graph. If I was to draw the graph of 2 sine x, that would go from 2 to -2. So y equals 2 sine x has got a total height from 2 to -2 is 4. 4 divided by 2 is 2, which matches up with that. A 3 sine x graph would go from 3 to -3, total height of 6, half it is 3, which matches the number in front. So by doing that, we can always get what the number in front of the graph should be, even if it's been moved up or down. So what I've got is, basically we're looking for the equation at the end of the day, but what I've done is I've drawn one for you already, and then we're just going to work through the steps just to prove that this is how we're going to do it. So the graph of 2 sine x should go from 2 to -2. We should know that. But because it's got a +1 on the end, it means that everything's been moved up 1. So the maximum height of 2 plus 1 is 3. The minimum height of -2 plus 1 is -1. Okay, so to get the total height, how far is it from 3 down to -1? That's a height of 4. Half of 4 is 2. So this was a 2 sine x graph. Now a 2 sine x graph should go from 2 to -2, but ours goes from 3 to -1. So both my numbers have been moved up 1. So that means it is a +1 that goes on the end. And that matches what's up there. To put it into simple terms, this is your method. So this would be a great thing to copy down. Step A, to get the value of A, the amplitude, that's going to be your total height halved. To get B, that would be the number of waves between 0 and 360, but I've already mentioned I'm not going to focus on that, okay? And C would be comparing what the maximum height should be to what it is on the diagram. So let's see these 3 steps in action. So example 1. The height of this graph is from 2 to -6. So how far is it from 2 down to -6? That's a height of 8. So it's bringing in some first year integer work here. Half of 8 is 4. So the A value of the graph is 4. There is only one complete wave here between 0 and 360, so B is 1. Now C is how far it should have moved up. So we've said the A was 4. So right now we know this is a 4 sine, it's a sine graph. They will tell you whether it's sine or cos as well in an exam. We know it's a 4 sine x. You can clearly see it's been moved down. So sine x graph should go from 4 to -4. But we've got it at 2 and -6. Now that's a drop of 2. So C is -2. The graph has been moved down 2 places. Now in the exam, they might just write it as y equals A sine x plus C, and they'll ask you the values of A and C. You would then write A equals 4, C equals -2. Or if you write it in the equation, you will still get full marks. Alright, so there's 2 different ways to answer it. A lot of people like to prefer to just go with the equation, so that's why I'm getting you to do that for my examples. Let's look at the next one. So I've got a graph here, and hopefully it's got that lovely valley shape, so it's a cos graph we're looking at. So the height of the graph, how far is it from 4 down to -2? That's a height of 6. So the height is 6. you half that to get your A value, which is 3. So at the moment we know this is a 3 cos graph. B is the number of waves. Again, I've only got one wave, so it's 3 cos x. Now the graph of 3 cos x should go from 3 to minus 3. Ours goes from 4 to minus 2. So that's clearly a shift up of 1. 3 has moved up to 4. So it's moved up 1 place. So C is really just the value 1. You don't need that plus sign in there. But the plus sign will go there when you write the equation. So y equals 3 cos x plus 1 is the equation of the graph. Look at another one. So this has got the lovely sine shape. Okay, it's a sine graph that's been moved down. Hopefully that's obvious. Now the maximum height, how far is it from 2 down to minus 8? That is a height of 10. Half of 10 is 5. So at the moment we know that this is y equals 5 sine. How many waves are there between 0 and 360? Well, there's one wave finishing and there's the second wave finishing. So B is 2 in this case. So it's 5 sine 2x. And then C is the movement. So if we've said it was a 5 sine graph, it should go from 5 to minus 5. But ours goes from 2 to minus 8. So it should be at 5, but it's as high as the number 2. That means it's moved down 3. So C is negative 3. Okay. Now one wee thing I've not pointed out, the seeing a sine graph, it's actually pretty obvious to see what the movement is because your sine graph should always start at 0. So if you look at my sine graph, it starts down here at minus 3. That matches up there. But I don't always talk about that because it doesn't work for a cos graph. It's only a sine graph it works on. But just to point it out. So that's the equation of that graph. My final example here. Have a quick look at this one. What do you think? Sine or cos? It looks upside down to me. What do you think? It's an upside down cos graph. But we're going to follow the steps. So how far is it from 6 to 2? That's a height of 4. So if my height is 4, my amplitude is half of that, which is 2. But we did say it was upside down, so A is negative 2. We know it's a cos graph, so I'm just going to fill in at the moment that we have a negative 2 cos. The number of waves for B, well, there is 1 wave finishing, 2 waves, 3 waves. So B is 3. There's 3 waves here. Now to decide the movement up or down. So it's nice, it goes in this order, A, B, C, the same order as the actual equation. So if we've said it was a negative 2 cos graph, that should go from 2 to negative 2. Don't let the upside down fact put you off. It should still go from 2 to negative 2. But ours is at 6. The highest number should be 2, but it's at 6. That's a movement up of 4. So C is 4, so you stick a plus 4 on the end. And that brings me to the last of the examples. I hope you've understood that and you'll have some practice to go to. Bear in mind there will not always be number of waves at National 5. Thank you very much.